We are still looking at more examples on how to calculate percentage yield. Now, this example here, let me try to create one that dinitrogen tetrafluoride can be prepared from 4 grams of ammonia and 14 grams of fluorine, according to the equation. We have ammonia gas reacting with fluorine to give us the nitrogen tetrafluoride, which is also gas, plus hydrogen fluoride. Fluorine is 4, 6, 10. This is 2. I think our equation is balanced. Fully stop. If 7.8 grams of dinitrogen tetrafluoride were produced, calculate the percentage yield. Calculate the percentage yield of dinitrogen tetrafluoride. Dinitrogen tetrafluoride. So this is a question. They say that the dinitrogen tetrafluoride can be prepared from 4 grams of ammonia and 14 grams of fluorine according to this equation. Now they say that if 7.8 grams of dinitrogen tetrafluoride were produced, we should calculate the mass, or I mean the percentage yield. Percentage yield of dinitrogen tetrafluoride. Now, you remember in the previous example, we said that we have steps that we are supposed to follow when we are answering such a question. We said step number 1 is determining the limiting reactant. So we look at determining the limiting reactant. And we said a limiting reactant is the one that has the least number of moles. So let's begin by getting number of moles of ammonia. They said we have 4 grams of ammonia, and the RFM of ammonia, NH3, is 17. So my calculator, where did I place my calculator? Is here, sorry. So this is 4 divided by 17, which gives me 0.2353 moles. Then we look at the number of moles of fluorine. They said 14 Fluorine is diatomic and fluorine is number 19. So 19 times 2, this gives me 38. So 14 divided by 38, I get 0.3684. Now, when you compare these two, you realize that ammonia has the least concentration, and therefore it is the limiting reactant. Now, if we need the amount of dinitrogen tetrafluoride that is formed, we must focus on ammonia. We said the limiting reactant is what is used to determine the final product or the amount of the final product. Now, let's try to determine how the mass of dinitrogen tetrafluoride that is formed. Now here, we realize that 2 moles of ammonia react to produce 1 mole of dinitrogen tetrafluoride. Now, what does it mean? This means that we need to interpret this equation to any way that is convenient for us. We can use molar interpretation, we can use mass interpretation, but of course, since they need mass, we want to the mass, we shall use the mass interpretation. So from the equation, we realize that 2 into 14 plus 3 grams of ammonia react to produce 14 times 2 plus 19 times 4 grams of dinitrogen tetrafluoride. So this is 17 times 2. This is 34 grams of ammonia produced. That is 28. 19 times 4. 19 times 4, 76 plus 28 to produce 104 grams of dinitrogen tetrafluoride. Now, the question is, or they already told us the amount of ammonia that reacted, since it's the limiting reactant. Now, if 34 produces that, then what of the 4 grams? 4 grams of ammonia will produce 4 times 104 divided by 34 grams of dinitrogen tetrafluoride. So 100 times 4 divided by 34, we get 12.24 grams of dinitrogen tetrafluoride. Now this is our theoretical math. I mean yield. That is the theoretical yield, but they say the actual yield is 70.8 grams. So you can even tell them here that calculating theoretical yield yield. So this is our theoretical yield, and the question said we should get the percentage yield, which is got from the formula actual yield divided by theoretical yield times 100. So what is our actual yield? 7.8. So this is 7.8 divided by 12.24 expressed as a percentage. So this is 7.8 divided by 12.24, and we get our percentage yield as 63.73%. That is our percentage yield, and those are the steps that we'll go through to get that. Thank you.